Okay, I'm still having some operational issues, but I think that we can keep going here. So we were going to look at this example, 15-19, and it says the 2 kilogram particle has a certain velocity, determine its angular momentum h0. Now, because angular momentum is always going to depend on some location vector r, okay, it has to tell us where that point is. So that's why it says h0 about the point 0. So it's about the origin right there. So the first thing we want to do is we want to get in here and we want to define what is going to be our vector for r. Okay, so here's our r vector, just like this. And then we need to devise the velocity vector as well. Okay, so then we want to go ahead and explicate. We want to go ahead and specifically say what are the r vectors for us. Okay, and so we're going to say here that r is simply, it's going to be 4 over and 3 up. Okay, and my momentum vector is going to be my mass times my velocity vector. So I'm looking at 2 times, and it's a 3, 4, 5 triangle, so that works out to be a 6, 8 in our vector, just like that. So if we pass the 2 through, then our momentum it turns into be 12, 16. Okay, just like that. Then this problem is really almost trivial at this point. Once we've defined r, once we've defined p, then we just take a cross product, and then at that point we're done. Okay, and so h is going to be r cross p. So we're looking at 4, 3 crossed with 12, 16, just like that. Now I did this earlier, and I used Calculate Infinity to use it. You could do it by hand. Any way you want to do it is just fine. But what that's going to come down to is going to come down to 0, 20. 0, 0, 28. Okay. Now, if you do your cross product on Calculator Infinity, or you do your cross product on your calculator, something like that, you have to remember to put it in as a 3-dimensional vector. Okay. So r, you want to put in as 430, and p, you want to put that one in as 12, 16, 0. Okay. And you can see right there immediately that we only have a z component in our angular momentum. So we might want to write it like this, 28. Okay. Okay. And so just sort of looking at my screen, all right, from your perspective, I've got r is here. I'm going to rotate that into my velocity vector. My thumb's pointing straight at me. So that's the direction of the angular momentum. Okay. Now you need to use it with your hand. Okay, here, here, your right hand, here, here, where your thumb is. That's where the angular momentum vector is. Okay. All right. So I'm going to set up for the next problem.